Once again, class. So for today's presentation, we're going to continue with the discussions on function notations and how we are going to evaluate a function. Now the equation x or y rather equals to x squared. So this represents a function that simply relates the variables x and y. So in other words, if you note this class that x and y are being related, and this is considered as a function based from its characteristics, then we call the x usually as the independent variable and the y the dependent variable because its value depends on the choice of your x. That's the name dependent variable. Whatever is the value of your x that you're going to input into the function, then whatever is the result, then that will be the value of your y and hence the dependent variable. So there is another way for us now to rewrite the function. So instead of writing y is equals to a certain variable x, then we just change the y into f of x, and we can rewrite this as f of x is equals now to x squared. So this is known as the function notation, and this is being read as f of x equals to x squared. Now this is the notation that we most commonly use to describe functions. Now, the independent variable is sometimes called the input because we have to put the value or put now the value of your x to be a certain number, and the result is what we call the dependent variable and what we call also as the output. Now this is sort like of a machine that we inputs first the first coordinate of an ordered pair, then the outputs, which is now the matching second coordinate. So just like a machine, so whatever is the value of your x here, if you're going to input it, so the function is a sort of a machine. So this is actually, could it be a formula? Could it be an algebraic expressions? Then whatever is the result of your x to be inputted into the functions, then we have our output or we have the dependent variable called the f of x. Now, when we are going to write an equation, okay, to write an equations in a function notation, so typically class, we solve for y in terms of x. In other words, what will be the value of your y when the value of your x is given? Then we are going to change the letter y to the symbol f of x. So this is how we notate a function. So say for example here, if you're going to write 3x minus 2y equals to 6 in a function notation, so first is that we isolate the variable x and the variable y. So it doesn't matter class where your variable x or y, as long as one variable, the variable x should be on the other side of the equation, then the variable y will be on the other side. So in this case, so I just transpose negative 2y to the other side to become positive 2y. Then we already isolated your variable y from your variable x. Then, since our purpose here, class, is to isolate the variable y, then we are going to divide both sides of the equations by 2. So doing that, we can have now both sides of the equations divided by 2, so that 3x divided by 2 minus x divided by 2 should be equals to 2y divided by 2. So if we're going to simplify this, so 3x divided by 2 is the same as 3 halves of x, while negative 6 divided by 2 is negative 3, then 2y divided by 2 is y. So by the property class of symmetry, we can just rewrite this as y equals to 3 halves of x minus 3. Then, according to the rule, we change your y into f of x. So the final answer would be f of x is equals to 3 halves of x minus 3. So this uh, function 3x minus 2y equals to 6 when rewritten in a functional notations or in a function notations is the same as f of x is equals to 3 halves of x minus 3 or 3x all over 2 minus 3, which will be easier for us now to evaluate class because whatever is the value of your x to be inputted here, then That depends now because your dependent variable f of x will have a result. So another example is this one. So write 10y plus 30 equals 5x in a function notation. So again, I want to isolate the variable y, so I need to transpose positive 30 on the other side. So I have now the negative 30. Then I'm going to divide both sides of the equations by 10 because I want to isolate the variable y. So this is also one way to divide both sides of the equations by 10. So each term will be divided by 10. Then we are going to apply the rules by simplifying so that we can simplify the result. So 10y divided by 10 is y. 5x divided by 10 is 1 half times x, or that is the same as x all over 2. Then negative 30 divided by 10 is negative 3. Then we change y into f of x. Then we just copy the other side of the equations to be 1 half of x minus 3. So therefore, 10y plus 30 equals 5x when rewritten into function notation is the same as f of x is equals to 1 half of x minus 3. Okay, so again, when you are asked to rewrite any equations, algebraic equations, into a function notation, so you just isolate your variable y, then solve for your y. Okay, you isolate the variable, not solve for your y, but you isolate the variable y, then you change now your y into f of x. And that would be now the function notation. Now, when we say evaluate a function class, so when a function is written as f of x, so if you encounter this f of 2, this means class that you're going to find the value of the function where the value of your x is equals to 2. So this is what we know as evaluating a function. So going back to our previous example, if the function is f of x equals to 1 half of x minus 3. So if you're going to evaluate the value, okay, of x equals to 2, then what will be the value of your f of x? So when we say evaluating class, we are not solving for x, but we are simply substituting the value of your x to be positive 2. So if we do that, substituting now the value of your x to be 2 into the function. So I have here 1 half times x. So I change now x to 2 minus 3. Then 1 half of 2, that will be 2 all over 2 minus 3. Then 2 all over 2 is 1. Then minus 3. Then we have negative 2. So meaning that when x is equals to positive 2, your f of x is equals to negative 2. So going back to that machine class, that when you input the value of your x to be positive 2, the output is negative 2. So therefore, this is what we call now the coordinate or the ordered pairs. So we can also rewrite this as a coordinate or an ordered pair so that f of 2 is equals to negative 2 is the same as 2 and negative 2. So if you recall class the concept of the functions in an ordered pair, so this is now your result. So here 2 is your input of x while the negative 2 is the result, which is now your f of x. Or this is the same as your domain. If the domain is 2, then the value of the range is negative 2. Now, what if we have another value of your x? Say, for example, if your x is equals to negative 2. So, if you're going to input negative 2 into the functions, then you are going to simplify it. So, again, 1 half of negative 2 minus 3. That is the same now as f of negative 2 is equals to the negative 2 all over 2 minus 3. So, we know that negative 2 divided by 2 is negative 1 minus 3, then the result is negative 4. So when you input the variable x equals to negative 2, the output is negative 4. So therefore, your ordered pairs or your coordinate now will be negative 2, and negative 4, indicating class that when the input is negative 2 as your domain, then the output, which is the range, is negative 4. So remember class that we are not solving for x here because we are simply substituting the value of your x to a certain number. So this is mainly evaluating. So there's a difference class of evaluating by compared to solving. Okay. Now, what if we have this expression? Okay, so 4 plus the square root of x plus 1. So the name of the function class, if g is g of x, so we can change now this to a g of x. Then we are asked what will be the g of 0 and what is g of negative 2. So again, all we have to do is we are going to substitute our value of your x to be 0 and the other one is x to be negative 2. So I just have here two functions of the same values. So here, if I have x equals to 0, then I will substitute the value of x to be 0 here. On the other side, if x is negative 2, then I will substitute x here to be negative 2. Then we are going to simplify this. So 0 plus 1 is still 1. So 4 plus the square root of 1. On the other side naman class, negative 2 plus 1 is negative 1, but still this is under the square root. Then we take the square root of positive 1. We also take the square root of negative 1 on the other side. Now, because we are talking class of real numbers, now you might be wondering why we have a value of undefined on the square root of negative 1 here. However, when the value of your x is 0, the square root of 1 is simply the principal root of 1. Then 4 plus 1 is 5. So when the value of your x is 0, then the output or the input is 0, then the output is 5. So we have an ordered pair which is 0 and 5. However, class, when the value of your x to be inputted is negative 2, then the result is undefined. Now, why is this undefined class? Because if you're going to take the square root of negative 1, the result is not a real number, but an imaginary number. So we just put here undefined because when we say undefined class, it means that it is not defined under the value of negative 2 as an input. So it's not really an error class, okay? So because square root of negative 1 is not a real number, that's the reason why we just say that g of negative 2 is undefined. So we are not solving an equation, as I said before. We are simply looking for the output of a function. So if there is no output, then we just say that the function is not defined for that input. So in this case, if the input is negative 2, then there is no output. So we just simply said undefined. So for this particular function class, okay, so negative 2 will not give us an output for this function 4 plus the square root of x plus 1. Now, what about this one? So we have f of x is equals to x squared plus 3x minus 5. Then you are going to find what is f of 3 and what is f of negative 2. So again, we just copy the given functions. Then we are going to substitute the value of your x to be positive 3 and the other one to be negative 2. Then we are going to simplify. So for the first one, we have your quantity 3 squared plus 3 times 3 minus 5. And for the other one, if x is negative 2 as the input, then we have the quantity negative 2 squared plus 3 times negative 2 minus 5. Then simplify. So 3 squared is 9, 3 times 3 is 9, then minus 5. For the other one, so we have negative 2 times negative 2 plus is positive 4. Then 3 times negative 2 is negative 6. Then we just copy negative 5. Then, of course, combine all the values, simplify. Then we have 9 plus 9 is 18 minus 5 is 13. Then 4 minus 6 is negative 2 plus negative 5 is negative 7. So when the function x squared plus 3x minus 5. And when you input the value of your x to be positive 3, the result is positive 13. So we have our coordinates or ordered pair of 3 and 13. So remember class that 3 is the input, 13 is the output. For x equals to negative 2, then the result is negative 7. So again, we have here our ordered pair or the coordinates of negative 2 and negative 7. So if you're going to plot this class in the xy plane, so you can do this, and if you continue substituting the value of your x by any number and see to it that there is an output, then if you're going to connect all the coordinates class, then you can see what figure we can find. So this is a second degree function. So typically class, this is a parabola. Yeah. And that's it. Okay, so again, you already have an idea class on how you are going to transform an algebraic functions into a functional notations, and at the same time, when we say evaluate a function, so all you have to do class is you are going to substitute the value of your x as the input, then solve for your f of x, and that will be your output. So once again, thank you, and until the next video class. Bye bye.